What is U-value and how does it prevent thermal bridging? Imagine a building that keeps the cold out in winter and the heat enduring summer without wasting energy. That's the goal of energy-efficient design, and understanding U-value is key to achieving it. The U-value measures how well a building part like a wall, roof, or window conducts heat. It tells us how much heat passes through a square meter of material for each degree of temperature difference. The units are watts per square meter per Kelvin. A lower U-value means the material is better at insulating and less heat escapes or enters. Think of U-value as the opposite of R-value. R-value measures how much a material resists heat flow, while U-value shows how much heat gets through. In simple terms, if you want a building to be more energy efficient, you want a low U-value. That means less heat loss in winter and less heat gain in summer, which cuts down on energy bills. Thermal bridging happens when parts of a building let heat bypass insulation. For example, metal fasteners, steel beams, or wooden studs inside walls can act as heat pathways. These bridges make the building less energy efficient because they allow heat to flow more easily through the structure. U-value helps identify these problem areas because it considers the whole building assembly. When engineers calculate U-values, they include the effects of thermal bridges. This shows where heat might be escaping or entering through conductive paths. If the U-value is high, it indicates more heat transfer, often because of thermal bridging. To prevent thermal bridging, designers use several strategies. One is continuous insulation, which means wrapping the entire building with an unbroken layer of insulation. This stops gaps where heat can escape. Another method is thermal breaks, which are low-conductivity materials like plastic spacers placed between metal parts to interrupt heat flow. Careful design of junctions and corners also helps. For example, reducing the size of steel beams or insulating around window and door openings minimizes conductive paths. Choosing materials with low thermal conductivity, like wood or special insulation materials, further reduces the risk of thermal bridging. When thermal bridges are minimized, the overall U-value of the building drops. This means the building keeps heat in during winter and stays cooler in summer, reducing the workload on heating and cooling systems. As a result, energy consumption goes down, and the home becomes more sustainable. In short, U-value measures how much heat passes through building parts and reflects the impact of thermal bridging. Lowering the U-value through smart design choices makes homes more energy efficient and comfortable. It's a simple but powerful way to improve sustainable home design and save energy over time.